Hello, my name is Mr. Rogers, and you are watching the video lecture for really a continuation of section 2-2 and also, I guess, 2-1, because we're talking about periodic table of elements and also talking about electron dot diagrams. So in our previous lecture, guys, we talked about how we place things in the periodic table of elements, and we've also talked a little bit about valence electrons. And so now we're really going to focus on those different groups or columns up in the vertical columns in a periodic table of elements, and we're going to focus on what that can tell us, just where the element is placed in the table. What can that tell us? Well, there's two kind of big rules, the two things they can tell us we're going to look at today. And we can use this periodic table to find the number of valence electrons in an element. So our two rules for finding the number of valence electrons in a group of atoms are, number one, if you are in groups 1 or 2, the valence electrons equals the group number. So if you have a group number of 1, you have 1 valence electron. If you have 2, you have 2 valence electrons. Secondly here, in groups 13 through 18, it is the group number minus 10 equals the number of valence electrons. So if you're in group 14, 14 minus 10 would give me 4 valence electrons. And so with just these two basic rules, we can look at a lot of different elements, and we can tell how many valence electrons that it has. And down the road, knowing how many valence electrons it has says a lot about how it bonds, what it bonds to, if it doesn't bond. And we'll talk a lot more about that as we go through this unit. But kind of knowing these, understanding these two rules is the big thing for today. And if we jump over then, what we're going to do is jump over to the periodic table. And I'm going to actually disappear. You'll still hear me, but you won't see me. So over to our periodic table we go. And as you can see, I've kind of hastily numbered them here. So on the left-hand side over here, we have group 1, we have group 2, and then group 13, 14, 15, 16, 17, 18. So over here, groups 1 and 2, we have hydrogen, lithium, sodium, potassium, rubidium, cesium, francium, all in group 1. And so regardless of their overall number of electrons, they have 1 valence electron. That's 1 in that outermost shell. We'll take a look at it again here too. If you're in group 2, you have 2 valence electrons. If you come over here to the right side of the periodic table, you can see in groups 13 through 18, remember that rule, so it's the group number minus 10. So all the elements here in group 13, so boron, aluminum, gallium, indium, thallium, I think there's 1 or 2 more that they found down there. But these all have 3 valence electrons. So again, 13 minus 10 would give me 3. Over here I've got this one circled, group 16, or oxygen group. And so it's 16 minus 10. So every element in this group has 6 valence electrons. Okay? And so those are our two basic rules for determining the number of valence electrons, those electrons in the outermost shell that an element has. Now, from that, what we can do is determine or create an electron dot diagram. And there's some basic rules for drawing electron dot diagrams. You write down the symbol, the chemical symbol. You find the number of valence electrons. We just talked about one way of doing that. And you draw the valence electrons in the following configuration. So here are 2 elements, and we're going to start with sodium here on the left-hand side. And I just want to point something out real quick. If you look on the periodic table over here, sodium has an atomic number of, kind of cross out there, of 11. So that means if it's neutral, it has 11 protons in the nucleus, but also has 11 electrons around the outside. And so we can count those. Remember, each shell can hold a different number. So in the first one, we have 1, 2. That's in our first shell. You can count them 1, 2, 3, 4, 5, 6, 7, 8 in this second shell here. And then in our third shell, again, we also want to fill that up to 8. You can see here there's only 1 valence electron left. So there's 1 valence electron. And what we do to create that electron dot diagram, that's just showing the number of electrons in this outer shell. So that's where you get this 1 dot for our sodium in the electron dot diagram, because it has 1 valence electron in that outermost shell. If we move over here to chlorine, you can see chlorine has quite a few more. If you find chlorine on the periodic table, it's actually over here. And it has 17, atomic number of 17, so 17 protons in the nucleus, but also then 17 electrons when neutral. Again, you can see in that first shell, there's 1, 2 in that first shell. Again, that second shell, it's going to be able to hold 8. That's our second shell. So there's 10. So now in the outermost shell, this third shell, again, we can hold up to 8. We count 1, 2, 3, 4, 5, 6, 7. So there's 7 electrons. 1, 2, 3, 4, 5, 6, 7 in the outermost. And then that's what's going to create our 7 dots on the outside of our symbol for chlorine. And so what I wanted to show you guys today is two things here. The first one is that how we use the periodic table to, just based on where elements fall, we can again show how many valence electrons they have. So our two basic rules. And then also here, recapping that if you want to create that electron dot diagram, it is all about the number of valence electrons. And so we determine the symbol, write that in the middle, Cl for chlorine. We find the number of valence electrons, and then we draw the dots showing that on the outside. And again, that electron dot diagram will then show me how many valence electrons an element has. So we'll stop there today, guys. I thank you, and we'll see you along the way.